Hello everyone, welcome to SPEC eLearn, the online learning channel dedicated to chemical engineers. Introduction to process control. In this video course, you will learn Introduction to process control, how process control systems work, elements of process control. Please subscribe to the channel. By subscribing, you will motivate us to produce more knowledgeable video content for you. Subscribe now before you forget. What is process control? Process control means to regulate, direct, or command a system so that the desired objective is obtained. Automatic process control is an important aspect of continuous production process to achieve stable operation, consistent quality of products, lower production cost, improved safety, and improved environmental performance. Process plant consists of several process equipment which are integrated in an orderly sequence to produce products in line with the design objectives. These equipment perform processes such as reaction, separation, heat exchange, fluid transportation, and storage. Each of these individual processes are controlled by operating parameters such as pressure, temperature, flow, level, composition, etc. Any deviation of these parameters from values at which the plant is designed to operate will make it difficult to achieve above discussed performance requirement. Process control system monitors the operation of each part of the process, identifies the unwanted changes, and initiates necessary corrective action. This figure illustrates a homogeneous batch reactor in which an exothermic reaction is taking place. The temperature rises during the reaction. The temperature is to be controlled during the reaction. To control the temperature, the contents of the reactor is withdrawn from the reactor and circulated through an external heat exchanger. A temperature indicator Ti measures and records the temperature of the reactor. Assume you have two systems, one with manual control and another with automatic control. How the temperature of the reactor system varies with the time with these two different control systems? The variation of the reactor temperature is illustrated in this figure. This is a plot of operating variable temperature versus time. Let us assume that the reactor temperature is to be maintained at 80 degrees centigrade. In the manual control, the cooling water to the cooler is regulated manually by the operator to control the temperature. Hence, it swings widely. In the automatic control system, the cooling water flow to the cooler will be controlled automatically with no operator intervention. Hence, it has much less variation. The temperature is maintained within a narrow range. This is the benefit of automatic control. Process control system. How does the process control system work to control the process parameters with a narrow range of the desired operating point? Let us move on to find out. by understanding what is process control system, who developed them, and how it works. Process control system is a system capable of monitoring and regulating the operation of a process or a plant. Process control system monitors the operation of each part of the process, identifies the unwanted changes, and initiate necessary corrective actions. Process control in a continuous process plant is a combination of two engineering disciplines, control engineering and chemical engineering. What is the role of instrumentation and control engineer, and what is the role of chemical engineer in developing a process control system? Process parameters fall into two categories, parameters to be monitored and parameters to be controlled. All the operating parameters measured need not be controlled. Some are required for monitoring the process conditions, and others are key parameters which need to be controlled. Depending on the criticality of the process, chemical process engineers decide which parameters need to be monitored and which need to be controlled. Control engineers decide on the type of instruments and develop the control strategies needed. Chemical process engineers also provide the input from the process point of view to select the right instrument. All these parameters are measured from the sensors installed in the field in the related process equipment and transmitted to the control room. The distributed digital control system DCS in the control room uses these inputs to control the process in automatic control mode. Some process plants may also have other process control systems such as programmable logic controllers PLC and supervisory control and data acquisition system SCADA. How does the process control system work? Every key operating parameter of a process have a predetermined value at which the plant has to operate so that it achieves the desired results. These predetermined values are called set points. Process control systems ensure that they do not vary from the set points. They initiate corrective actions if they detect any deviation from the set limits. The key element of a process control system is the closed loop control. Plants usually have several hundred individual control loops, each of which controls one aspect of a particular process. For example, in distillation column, it could be the column pressure. In a compressor, it could be the suction pressure. In a reactor, it could be the feed flow rate. The function of the control loop is to ensure that a particular parameter is maintained at its set point and does not vary beyond a preset upper limit and lower limit. Controlling the parameter at its set point is not just sufficient, but it must act quickly when the deviation is detected so that it does not impact quality or the production. Having understood how the control system works, let us now move on to the elements of process control. The control loop uses three elements: measuring element or sensor, controller, and final control element or the control valve. How do the three elements work together to accomplish control of process variable? Illustrated in this figure is a distillation column operated by automatic process control system. The column has several key process variables that need to be controlled. For example, feed rate, reflux flow rate, column pressure, reflux drum level, etc. Let us consider one of the key variables, the pressure, for our understanding of process control system. This is done by a pressure controller. The process control loop for pressure control is called PIC, pressure indicator cum controller. The PIC controls the pressure at around the set point. The set point is the desired value of the pressure at which the column is designed to operate. The sequence of actions by which the PIC functions to control the pressure at the set point is shown here. The pressure sensor senses the pressure. Measured variable is transmitted to the PIC. The PIC compares the received signal with the set point. Based on the deviation, the controller sends an output to the control valve. The control valve receives the output and manipulates the process variable. The elements of process control for the pressure control system of the distillation column is shown in this figure. In our example of distillation column, the set point of the pressure controller is 24.5 bar. If the measured variable is 24 bar, it is below the set point, and the controller sends a signal to the final control element to reduce the cooling water flow to the condenser, so that the pressure is increased back to 24.5 bar. What is the final control element? The final control element is one which controls the process throughput or utility flow rate to the process. It responds to the commands from the controller and make necessary adjustments. The final control element is the control valve, and in our example, it is a pressure control valve, PCV. The PCV regulates the cooling water flow to the condenser and bring back the pressure to the set point. So what are the elements of process control? It is explained here with an example of pressure control system for the distillation column. Sensor, the pressure sensor such as the pressure gauge. Controller, which permits the set point to be set at the desired pressure value and generates an output based on the input. Final control element or the actuator, the control valve that regulates the cooling water flow to the condenser. The block diagram showing the blocks of a control system is shown in this figure. In most cases, the error term is used to calculate the controller output. The error is equal to PV minus SP, where PV is the process value and SV is set point. The variable that the control valve regulates is called the manipulated variable. This could be the feed flow or reflux flow in the case of a distillation column, or cooling water or steam or any other utility flow rate which has an effect on the process variable. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.